What's up, you pussy ass bitch? My name is Flynn Wilson. And you're a pussy ass bitch, and this is a Flynn Wilson podcast. Timer, be focused. I went garage sailing this morning, and I'll show you some of the stuff that I got. I didn't get much. This is my calculator, but I got some of these, which will be, I reckon I'll make like $100 profit off. Maybe a bit less. Maybe a little bit less. Kind of a neck condition. Maybe. We'll see. We will see. Okay, let's study. Equilibrium. And I got some shoes that I think might be Nike Air Jordans, but are probably fake. But I don't know. Let's search up equilibrium principle NCAA level 3 chemistry. Solubility equilibria. Acid base equilibria. Watch this. Sure, fuck it. Complex ions. Let's search complex ions. Mainly you. Hopefully you're a good video. Okay, let's go.
Hi there everyone, and welcome back to Chemistry 3.
I'll start with you.
Let's move on to today's topic. And instead of just going...
Whoa. If the Air Jordans are real though, they could, I reckon, like 150, 100, 150. I don't know. I don't know enough about it. I don't know enough about shoes. I just know that Air Jordans sell well.
Material me teaching you guys. I want you guys to think critically about a few of these questions I've got on the screen, and then we're going to answer them over the next 10 or 15.
By the way, oh fuck's sakes, why did I do that?
Minutes when we go through the teaching portion. So,
by the way, I bought those Air Jordans, which might be fake, so they might be worth nothing. I might have to just chuck them out. Even fake ones would sell like alright, wouldn't they? Like $5 for a fake pair. I bought them for 50 cents.
I've got three equilibrium.
He wanted $1. He didn't get it. For the calculators, that guy wanted $25 each, which is like a reasonable price. Wait, no, he wanted 17. He wanted them for both for $35. He didn't get it. He got $25. Let's go.
Expressions for sparingly soluble solids up on the screen right now. With regards to the first one that contains silver carbonate, the same compound we saw in our warm-up, is it more or less soluble when I add acid to it? So imagine I have a saturated solution of silver carbonate. Will it become more or less?
I didn't even do my thermodynamic. Fuck's sakes. Idiots. Let's just delete that shit. Or Control Z. Check it down. Date. So it should be the other way around then. Date. What? I did not put the right date there. 13th of the 11th. Why did I put second? What the fuck? I'm so confused. Let's have a look at this, the history. Dude, you're an idiot. That's the 12th of the 11th. What did I put? On the 11th. That's the 13th.
Soluble. Will more of that solid dissolve? Will more of it actually precipitate out? Now, what do we think? Ellie, you had your hand up.
Are there fucking kids in the class? What the fuck is going on?
Ooh, you think the acid... Ella, you had your hand up.
It sounds like a fucking 5-year-old.
Ooh, you think the acid reacts with one of those products? And you said, which product is it? Carbonate ion. Less of it to replace it.
Yeah, that fucks right, isn't he? Doesn't what happen if you add an acid? An acid is a proton donor. So it doesn't CO3 2 minus accept a proton or two, like HCO3 minus, I think it becomes. Like it accepts one proton, which means that the reactants are decreasing, which means that the products are decreasing, sorry. Because they're decreasing, it becomes more soluble because the products are decreasing, so the reactant shifts to favour the products. So less reactant, it dissolves more basically. That's what
You're
I think
thinking of
happens.
what we called the Chatelier's principle last year at level 2, right? You know, what would drive the reaction forward, maybe? Nelly?
Well, I was going to say that there might be an acid-base reaction, but no, because that's a salt.
In solid form,
That was a stupid thing to say, Nelly. Come on, Nelly.
it is, right? But
Yeah.
there's a small amount of that solid that is able to dissolve, and so the solution does contain some of those ions in very small amounts, right? And so what
I
you're
think maybe
suggesting,
it would precipitate more into Ag2CO.
Fuck are these pussy nerd farts saying, dude? Say what I just said.
so maybe it goes the other way.
But that doesn't make a lot of sense.
Maybe we'll have a look in just a minute. But let's look at the second equation, see what we think happens there. So we have silver chloride this time, a
Right.
sparingly soluble solid, but some of it does dissolve to form silver ions and chloride ions.
Yep.
Will it be more or less soluble when ammonia is added?
Ammonia. Ammonia is NH4, right? Doesn't nothing happen? Cl minus is a weak conjugate base. Very weak. Guess nothing happens.
Ammonia, of all things.
I'd say nothing happens.
What are some properties that we know of in regards to ammonia?
It's an acid,
Yeah, yeah.
weak acid, donates H's.
No, but I mean, it's a base.
It is a base. I heard you say that too.
Fuck! Ammonia, is that NH3 sort of accepts H's?
Uh,
The forms of ligand. Is that useful?
ooh. You nailed two things. It's a base. It forms something called ligands, which is a new concept for many of us, which
What the fuck are ligands?
I'm sure we'll talk to later
I've heard that before, I can't remember.
today. Okay, and
Okay,
the
that guy was
third
smarter than me. I'll give it to him. That guy was smarter than me.
equation, what do we think is going to happen with the solid? Will more or less dissolve when zinc hydroxide is what we've got? And if the pH is really acidic, less than 4, will more or less of it be able to dissolve? What about when it's kind of in the middle, like not too acidic, not too alkaline, between 4 and 10? And what about when the pH is really alkaline, above 10? These are all 3 different situations, and they may have different answers. So does anyone want to speak to one of those scenarios? Maybe you can't predict all 3, but can you tell me what you think will happen in one of those scenarios?
When pH is below 10, 2OH minus reacts with the H plus is available, so it becomes more soluble because then, yeah, less products, so the reactants, so the reaction favours the right side, so more products form more ions, and so it's more soluble. Already the pH is very low though. It's very high though, it's very basic.
So it's zinc hydroxide, right? we're either in really acidic or really alkaline conditions or somewhere in between. Yeah. Timmy?
If you're in acidic conditions, which can be protein H plus ions,
Yes.
bond with OH minus produce water,
And
thus more zinc hydroxide would dissolve because OH ions are being used up.
so
for everything else.
similarly to what I think Ella said for the first one, shifting equilibrium to the right towards the products to replace those hydroxides that might have been consumed in that neutralization reaction towards the
Fuck did
products.
that pussy nude
Similarly
fuck say?
to what I think Ella said for the first one, shifting equilibrium to the right towards the products to replace those hydroxides that might have been consumed in that neutralization reaction. Yeah. So that's a really good answer for what happens when the pH is acidic, less than 4. When it's in between, do we have any guesses?
Pretty insoluble. The
Pretty insoluble.
transition metal hydroxide.
Yeah.
So that's soluble.
So you're thinking without a lot of hydrogen ions to neutralize the hydroxides, it's not going to really help it become more soluble.
Yeah.
It's probably going to become pretty insoluble there. And what about at really alkaline pHs?
It's already at alkaline.
We have a really large concentration of hydroxide. What's going to happen?
Oh, is it? Well, there's already OH there. It's already extremely alkaline, isn't it? But if you're saying by a higher pH we're going to add OHs, then it's going to be the opposite effect, where it's going to become less soluble.
I don't know why, but it does become soluble. But soluble in base.
So we think it's actually, it seems kind of contradictory. You can't explain it in terms of really what we know about Le Chatelier's principle right now yet for many of us. When you have an excess of hydroxide at a high pH, wouldn't that shift it towards the left to form more reactant? You would think? You would think so. But Oscar is saying that there's something unusual happening with really large concentrations of hydroxide that might drive it the other way.
Yeah, I think it forms zincate. So it's actually maybe a chemical reaction in that sense.
It forms actually a complex ion, really, yeah. So we're going to be looking at something called complex ions today.
Oh, okay. Let's go.
But the first one doesn't require knowledge of a complex ion. The first one's just, like you said, it's an acid-base reaction where the carbonate's going to be removed by the acid at a low pH, and that will just drive it towards the right. That's typical Le Chatelier's principle stuff that we know from
That's easy.
last year. So let's go into that
Isn't that
scenario.
effect?
Acid on solubility. So this slide's all about acid. We will look at base later on. So
Cool.
if the salt contains a carbonate, this is the first of the 3 equations we just predicted. It will
This video has 37 views. I'm one of them. This video is fucking lit. Zach Williams has 78 subscribers.
dissociate into its ions, of course. And the acid can neutralize carbonates. And this would reduce the concentration of carbonates. And accordingly, the principles of equilibrium say that if a product is removed, and in this case carbonate is used up, the reaction will increase in the forward direction, favoring the formation of more products to replace the depleted carbonate. So acids increase solubility if the salt contains a carbonate. That is the main message there.
The fuck's going on? That pause the video? What the fuck's happening? Oh, they're copying down notes. I forgot how school works. That's right. You sit there and you copy down notes. Oh, that's funny. If the salt contains a carbonate, Ig. Alright, let's hurry up. Fucking.
Okay, so question?
That's not relevant right now.
Okay. So I think this is a good way to ease into this topic of how solubility can be adjusted with pH, because this is something we
Got
could
a kid's work, man. You got a question? Oh, it's not. Actually, no, it's not related to this topic.
have predicted last year. It's we're mostly familiar with the idea that carbonates react with acids. If you've researched any sort of like ocean acidification thing, you'd be familiar with that.
Fuck,
To
are
make
you
it- Look at the
serious?
second.
Let's go.
So we've answered the first scenario, so I've just bolded the correct answer. It will become more soluble, okay? Now let's look at the second scenario.
Second scenario, dude, I don't know. I think nothing happens, but maybe I'm missing something. Like NH3 is added as a base, apparently, because it accepts protons to become NH4+, right? It's a weak base. So it will accept protons. So if you add it there and they're aqueous, okay. So there's H2O there. Then that means that the solution will become more basic. We'll add more OH minuses in there. The solution is more basic. We have more OH minuses in solution.
Where we have silver chloride. Is it more or less soluble when something called ammonia is added? Okay, so NH3, ammonia, we talked about how it's a base. We talked about how it might form something called ligands around the transition metal ion. Let's have a look at it. Now, in this case, ammonia is a base. So we're looking at the effects of this type of base on solubility. And in this scenario, ammonia or hydroxide, in a lot of cases, will form something called a complex ion around select transition metals. And I'll go into what a complex ion is in just a minute. So when a base like ammonia is added to this, it will react with the silver cation, therefore reducing the concentration of that ion in the solution. And what does that mean? Which way will equilibrium shift now that that silver ion's been kind of consumed a bit? Yeah.
Dissolve more.
More of the solid should be able to dissolve to replace that free silver ion, right? Because it's been used up. It's locked away in the form of a complex ion. Cool, so we understand that. So the product is removed. The reaction will increase in the forward direction again.
Oh, for fuck's sake, not listening. Oh, dude, I was not listening, by the way. If a sparingly soluble salt contains a cation, if a sparingly soluble salt contains a cation, okay, let's go back to when he started explaining this. You aren't going back, okay?
Let's have a look at it. Now, in this case, ammonia is a base. So we're looking at the effects of this type of base on solubility. And in this scenario, ammonia or hydroxide, in a lot of cases, will form something called a complex ion around select transition metals. And I'll go into what a complex ion is in just a minute. So when a base like ammonia is added to this, it will react with the silver cation, therefore reducing the concentration of that ion in the solution. And what does that mean? Which way will...
Right, that's how complex ions work.
equilibrium shift now that that silver ion's been kind of consumed a bit. Yeah.
To the right, dumbass.
More of the solid should be able to dissolve to replace that free silver ion, right? Because it's been used up. It's locked away in the form of a complex ion. Cool, so we understand that. So the product is removed, the reaction will increase in the forward direction again. This science. Great question. I'm glad you asked. I'm magically going to create.
The fuck are you talking about? Great question. No one even spoke. Or there's some little kid in the background speaking.
Any questions about this?
What is a complex ion?
Great question. I'm glad you asked. I'm magically going to create a slide just now about complex ions. Okay, here we go. Complex ions.
Classic LW.
And I have a good link to a fantastic website about complex ions called ChemGuide. It looks like it was made in like 1994, but he updates it every year, and it has all the knowledge you need for high school level 3 chemistry. So a complex ion has a metal ion at its center with a number of other molecules or ions surrounding it. So it can have neutral molecules that are attracted to that metal ion, or it could have other negatively charged ions attracted to that metal ion. So we have a bunch of complex ions here. So overall, the whole species has a charge. And, oh, what kind of shape is this? Where we have 6 water molecules.
Dude, that's octahedral, you dumb fuck. Let's go. Wait, how the fuck is it H2O? But the O is also bonded to the Fe. You're not making sense.
Attracted to an iron in the center.
That's octahedral, you fuck. What?
Yeah, octahedral, eh? And so we got another octahedral. Well, all these examples here are octahedral. They're not always octahedral. So you can see the formula here for this. This is iron with 6 waters attracted to the metal center. And you can see that the lone pairs are what are attracted to the metal center, because obviously negative charge is attracted to the positive charge of the metal. And you might be wondering what kind of bond is actually happening there. Is this an ionic bond, covalent bond? What is it? It's a form of a covalent bond, you could argue. It's a covalent bond that we call either a coordinate bond or a dative bond, or dative. I'm not quite sure how to pronounce it. It's one of those two where they're attracted to the center and they form a form of covalent bonding. But this is unique, covalent bonding, because we know covalent bonding is the sharing of 2 electrons. But if you look at these pictures, both electrons are coming from the same species. So each water molecule is donating a whole lone pair to make that covalent bond. Whereas typically in molecules, when we make covalent bonds, there's typically 1 electron shared from one atom and 1 from the other to make a covalent bond, right? That's typically how we form them, a sharing of 1 electron each that shares and donates. But in this one, both electrons are donated by the same species to form that covalent bond. Nice.
The question I had before was, you asked me yesterday in your email to ask if you had.
Thank you. Haven't. I'll do it.
That's all right.
Yep.
You got time.
Yeah, I'll do it today. But yeah, thanks for reminding me. After this, we'll do that. So if you're wondering like where the charges come from, because if you look at the top right-hand corner, like any good diagram at level 3 when we're drawing...
Yo, that's lucky fact. Fe 3+. Guess it's missing 3 electrons.
These structures with charges, remember we practiced drawing polyatomic ions last term with structure and bonding, and we'd have to write the charge outside the square brackets, all that good stuff. If we look at this one, it has a charge of 3-. We could probably figure that out. It's not just some magic number. What's the charge of aluminium? 3+. And how many fluorides have we got? 6. And each one has a 1- charge, so 3+. And you add 6 minus 1 charges to it, 3-. Yeah. Yeah, so you can figure it out typically. It makes sense, right? Structurally, it makes sense.
Bingo.
Cool. So that's what a complex ion is.
Cool. When the fuck
Now,
is that
these are the
coming
ones you don't need to memorize, but we'll...
Zinc, it's like Zec and Zalp.
be given to you in the resource sheet on the exam.
What? No, it's not. Let's go. Oh shit, they do give you all those complex ions. Yo, what the fuck? Alright. What the fuck do I remember Zack and Zelp?
This list of complex ions will be given to you. Okay, but these are the 9 you should expect to encounter.
Okay. I'll be back, dude. I'll show you guys what I bought. What I bought at today's garage sale. Oh, man, fuck. And the bag still? Where did I put those? Bang, bang, into your heart and bang, bang. Na, 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 na. Here they. Oh, fuck's sake, stupid fucking camera. Work, you fuck. Bang, bang. Bang, 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 bang. Bang, bang. I really don't know where I put this. Oh, right there. Oh, but dude, the camera, is it even on? It might be on. Fuck's sakes, photo booth. Why did it stop in the worst fucking frame as well? Mm-hmm. Nah, there's no way these are real. These seem terrible. So it's 4Y, Nike Air Jordans 4Y. Air Jordan 1s. How do you tell what ones they are? Air Jordan 1s. These shoelaces suck ass. Damn it, camera, why aren't you working? Bang, bang into your heart and bang, bang and... I'll go on eBay. Nike Jordans 4-1. Oh, that's annoying. It doesn't have, it's got like a black tech. Well, which one is this? How do you tell? 1. They're like different ones. So it's like 1 and 10 and stuff. Is that what's going on? Whatever. Bang bang, bam 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 bam. How are they new? But bang bang into your heart and bang. What are these called? I think that those are the exact same ones, but they're new. White mustard, but it says white mustard instead. Go to the next page. Just don't go to sold ones then, man. Search. Bang bang into your heart and bang bang. Oh, what the fuck was that? They all look the same. They look relatively similar, but no. Why are they all brand new? Are there any used ones? Are they only good if they're brand new? These ones are pre-owned. Pre-owned. Nothing's even showing there. What the fuck? Whatever, man. Let's start the timer. Is my camera working yet? Oh, for fuck. Now it's working. I fucking already took the Air Jordans away. Okay. I'll just show you guys the calculators. Oh, but I would really like to see those Air Jordans in the future, wouldn't I? Okay, I guess it'll take 5 minutes to get them. These are the calculators. It's got Vivid on it. It's got some shit on it there. Turns on, it works. I think this one's low battery. Got batteries. Alright. But it works. Just got low batteries. They're in rough condition. I bought $25 for both of them. He wanted $35. He got $25. He was not willing to budge though, huh? I came at him with an insulting offer. I said $15. He's like, no. I'm like, all right, fine. Okay, so are you wanting to negotiate? I'll do $20. He's like, okay, $30. And I'm like, how about we meet halfway? Let's do $25. So I think I'll be able to get like, I don't know. Worst case scenario, I can't get the Vivid off. I'm assuming I can. I can't get the shit off, so I have to end up selling them for like maybe $40, maybe $30 a piece. Worst case scenario, $60. That's like about $50 profit. That's worst case scenario. I'll go get the shoes because I know that future me. What'll probably happen is I'll probably go to garage sales in Christchurch as well. Then I'll kind of make a bit of money through doing garage sales and flipping. I think there will be more in Christchurch as well. Bigger town, so that'll be pretty dope. So I'll probably know quite a bit more about garage selling. I'm only just starting doing it. I think I did it last weekend. I think I might have done it the weekend before that. No, I think I just did it last weekend. So this is my second time going. I've watched a couple of videos on it. You kind of get the basics. And you know, like, because I bought this calculator, so I knew that these were worth quite a bit. And I looked at it on Train Me as well. The guy included in the Facebook listing, so I just asked if I could go in and get the graphics calculators. But I'll show you guys these shoes as well. Oh man. Bang bang. Okay, so here's the shoe. Air Jordans. These laces are just shitty quality though. Nike. So I don't know if these are fake or not. Laces again. Not there. Dude, that thing is not good. I think it might. What the fuck? Whatever. I don't know. But I reckon that could be, if they are real, like $100, $150. Maybe like $100. But we'll see. We'll see. I got it for 50 cents, so. Oh. Bang, bang, yeah. The dude, he wanted $1 for those shoes. He didn't get it. He didn't get $1, mate. He didn't get $1. He got 50 fucking cents. And I had $1. I handed him $1. I'm like, you got change for $1? That's what he wanted. Motherfucker got 50 cents. Let's go.
After, not all of them, but one or two of them maybe at most, on the exam. So we just looked at the case, I think, of silver with the ammonia ligands attached to it.
It's complex ion.
We talked about how the solubility of silver chloride would increase when we introduced ammonia, which is a base, but also able to form complex ions.
Bases,
What are ligands again?
So ligands are these species that bond around a transition metal in a complex ion that donate a pair of electrons.
A ligand is just a transition metal that can form a complex ion. So like Zach and Zalp, so zinc, aluminium, and copper. Zalp, zinc, silver, No, that one's aluminium. Zach was silver. That one's aluminium, so ZAL. And lead, PB.
Will we ever?
But I see copper there. But I also see cobalt. Guess that can form a complex ion as well.
No.
Zach can tell us wrong. I don't know. There's Fe there too.
Yeah, the ligands are the molecules or ions that bond around the central atom in a complex ion.
Does
Okay.
anyone else get like a random feeling of relief every time you ask a question? Do we need to know this? No.
So, let's move on. Keep moving through it. So we answered this question, right?
What did that
With
just
silver.
say?
So,
Does anyone else get like a random feeling of relief every time you ask a question? Do we need to know this? No.
so let's move on. Keep
Do we really need those? That's what I heard.
moving through it. So we answered this question, right? With silver chloride, we could increase the solubility when adding ammonia. Why? Because ammonia is what we call a ligand. It bonds around that central metal to form a complex ion, removing the silver from the system. So equilibrium shifts to the right, forming more products. More will dissolve. Cool. And we got, sorry?
NH3 and OH minus are the two ligands
Yes.
that are relevant to this reaction.
There's one other, some cyanide right there, CN, right?
Okay.
CN, that's typically it. But you can see a lot of these species have either ammonia or hydroxide.
Bang, 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 bang into your heart and bang.
Just
bang
looking through it, we
into
got
your lungs,
lead,
and boom,
nickel,
boom, 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 boom. But
silver,
what do you
zinc,
think, Finn? Do you think those
aluminium,
Nike
zinc,
Air
can.
for real?
Copper.
How much money did we end up making on
There's
them?
just
Do you
one
remember?
instance where it's not hydroxide or ammonia. No, sorry, there's two
remember?
instances of CN.
Okay.
Look at my beautiful face. The sunlight makes my face look so beautiful.
Cool. Complex ions.
Sheesh.
Oh.
Last one. This one's kind of the interesting one. Yeah.
The first one should be 2.
Thank you. Yep, you're absolutely right. That should be a 2 there. I'll balance that afterwards.
There should be a 2 in front of the AG. Fuck's sakes, I forgot about that at school. There's always those one fucking pussy nerd farts I think they're smarter than the teacher. But the most basic here is AGT CO3 goes to AG plus CO3 2 minus. I believe there should be a 2 in front of the AG soon. Shut up. That's Martine vibe art for us. Martine,
Yeah.
if you're watching this, fuck
Yeah,
you, pal.
please call me out when you see that. With the last one, it's kind of tricky. This did appear, I believe, on the regular level 3 exam recently, a couple of years ago. It was a favorite problem I like to do with classes over the last couple of years because
Gee,
it
what
did
the
appear on
fuck is
exam.
going on
I don't think it
now?
was a scholarship one.
Jesus Christ.
I think it was a regular level 3 exam when this question appeared, I believe. This question here, where it asks you the exact same 3, like, is it more or less soluble at each of these pH ranges?
That's like my favorite question.
No, it was at least a couple of years ago, and I believe it wasn't scholarship, even though this seems kind of almost like scholarship level in terms of understanding.
Scholarship? What the fuck? Basic shit, bro.
Okay, so we said at low pH we know what's going to happen, yeah? We know that, it's going to be really acidic, it's going to consume the hydroxides, so more will dissolve.
Yep.
pH in the middle, what's happening there? Okay, we'll figure it out. So,
Nope. That's just adding H3O plus. So like I said before, if you add H3O plus, it will react with the 2OH minus there, present, to form just normal water, which decreases the OH minus concentration, which means that the equation leans more towards the right again, like I said before. Fuck you, pussy.
Yeah, okay, so if a salt like zinc hydroxide, which has hydroxide in it, if we have it in the pH range below 4 or 10, equilibrium shifts to the left to decrease solubility. And that's because in that range, we have like a medium amount of hydroxide, not too much acid to neutralize the hydroxide. And the addition of these hydroxide ions, as we slowly increase the pH from 4 to 10,
Hydroxide? What? You're decreasing it. It's going from 10 to 4, not increasing it from 4 to 10.
means equilibrium shifts to the left because we're adding more product. We're increasing the...
Hydroxide Z and OH2. That's Z and OH2. We don't have Z and OH2. Oh wait, do we? No.
Product concentration of
Yeah, it will decrease solubility. Yeah. No shit. But you're not. You're adding H2O plus.
hydroxide ions.
So you increase solubility.
No, you decrease solubility. You form more precipitate.
Oh, okay. Wrong way around.
In the range between 4 and 10, you form more precipitate because you're increasing the concentration of free-flowing hydroxide ions, which is one of the products if zinc hydroxide is the precipitate we're looking at. Now, increased solubility happens, and this seems kind of contradictory at first, at a pH greater than 10. So if we keep increasing the hydroxide concentration, this weird thing happens where all of a sudden the solid's like, hey, I want to dissolve now. This is cool. There's lots of hydroxides in there, which is why I precipitated in the first place. But now, oh man, all these hydroxides, let's dissolve.
Alright, fucking explain yourself, you nerd fuck.
Sorry,
You'd
I
be
was saying my
sick.
throat's hitting though. I was miming. Sorry,
You'd
I
be
was saying
sick.
my throat's hitting though. I was miming it.
And that's because
That's weird.
if you maybe just read the slide right there, or if you look carefully at here, zinc hydroxide, if we react with enough free-flowing hydroxide ions in solution, we form actually a complex ion that's soluble because it's an ion, it dissolves. So if we overload the system, really high pH, lots of hydroxide ions are present, it forms a complex ion, and more will dissolve as a result of that. So because zinc ions are being removed, as we add hydroxide to form the complex ion, solubility will increase in the forward direction to replace that product.
Not gonna.
Cool.
Bang, bang into your heart and bang, bang.
Forms more precipitate. Yeah. Equilibrium shifts to the left in that range because hydroxide is pushing it towards that.
Oh, fuck's sake, dude. Fucking
Stop
taking
right
nuts,
there
man.
for now and actually apply this to some problems.
Yo.
In effect is our next topic.
Let's get out the book and let's do some problems. Look at my calculators. I've got my calculators ready to do some problems. Dude, I turned on this this calculator and it said low batteries. I tried to barter the price down. I was like, he's like, you know that they're worth a lot. I'm like, oh yeah, but it's got Vivid all over it. This one's got low batteries. It's literally just fucking batteries in there. I forgot. I genuinely thought that it was like a fucking like a battery that you had to replace. Not just fucking AA batteries. Double AA batteries. Bang, 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 bang into your heart. And maybe I'll keep one. What if I do that? Dude, I could do that. Keep this as my fucking... Oh shit. I might do that. I might keep this one that's got a fuck ton of Vivid as my actual... my actual calculator, and then sell my actual my one, my good one. That hasn't been fucking drawn on by a 5-year-old. Maybe.
Topic. In an aqueous solution, if that
Dude, the class is about to do some fucking questions. Let's go class.
aqueous solution already
If an aqueous solution contains either one of the ions already present in the precipitate, then this will reduce the solubility of the salt, since the presence of the common ion will move the equilibrium towards the side of precipitated salt.
Contains either one of the ions present in a precipitate, maybe you're adding to it or that you're wanting to form.
Yeah, it becomes less. If you're increasing the ions, then it becomes less, because it just favours the left side of the reaction.
Then that ion that's already present will reduce the solubility. Because, just like what we've been talking about with Le Chatelier's principle for the last hour, that presence of that ion shifts equilibrium to favor the formation of the reactant, quote unquote, the salt. It's not really a chemical reaction, it's a physical change when it dissolves, right? But
I'll be back. I'm gonna go put our pizza in the oven. Bang bang into your heart. In trouble. Bang 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 into your heart.
Hey, yo, Flynn, this pizza we're about to eat is gonna be nice. It's gonna be nice. It's gonna be nice and yummy.
It's different. It's made in Italy. Dude, I can't stop looking at myself. Why do I look so muscly? Look at my forearms. Why are they so big? I don't know. I just wanna... Oh, I better stop. You're so cringe. Shut the fuck up, Flynn. Shut the fuck up. Your charisma doesn't work. That's the whole point. That's the whole point. The charisma there isn't working because I don't give a fuck. I don't give enough of a fuck to make my charisma even work, mate. I'm not scared to take L's. I want to take L's. I actively take L's. Sometimes when I'm taking too many dubs, I'll go out there and take a fat fucking L on purpose. I don't give a fuck. Because there's no such thing as L's. When I'm saying taking L's, I mean temporary L's. I'm taking too many temporary dubs. I want to be taking a fuck ton of L's. The more L's you take, the more W's you take. But my definition of an L, I keep on saying there's no L's. Your definition of L is different from my definition of an L. Because I believe, from your definition of an L, there is no L. Loss. Bang. Loss. That's it. End of story. You lost. You lost a game of basketball. You lost a game of basketball. I don't see that. Right? What I see is, you lost a game of basketball. That's a great That's a great lesson. You will get better and you will win the next game. If you lose that, it's an even bigger fucking lesson. Right? So you improve and you get even better. You get stronger from losing. Right? So that's the whole point of my charisma. Sometimes I purposely am a fucking queer cunt. I go to fucking kiss you. You know, I'm like, you know, being a fucking weirdo because I'm not afraid to show L's, to take L's. Take L's. Temporary L's. I want to take L's. The more L's, temporary L's you take, the more future dubs you take. L doesn't stand for loss, it stands for lesson. There you go, future Flynn. So stop saying, you're cringe. But you won't be, right? Because we fucking improved, right? We stuck with this mindset, right? Right, future Flynn? My man, dap me up. Anyways, this pizza is going to be fucking nice. Let's do some more schoolwork, pussy. I was thinking, like, what if I lose this YouTube channel? Does YouTube just delete, like, surely it doesn't have, like, room for, like, infinite data, right? I just delete this YouTube channel after a while? I don't know. That'd be fucking annoying. Because these are fucking relics. So much is to be learned from watching this video in the future. Why is it still paused? Fuck. Okay, let's
But it's
go.
formation, the left-hand side of this equilibrium, the formation of more salt. Because, you know, with those ions there, we're increasing the concentration of one of the quote-unquote products, so it favors the formation of that solid. So silver chloride would be less soluble in seawater rather than drinking water, because seawater obviously contains a lot of salt. And in salt, you have chloride ions, right? So in seawater, there's a large concentration of chloride ions. Those chloride ions will shift equilibrium to form more silver chloride. Less silver chloride would be able to dissolve than in drinking water or fresh water. Make sense? Some nods? Cool. And that's the basic principle of common ion effect. There's a common ion. That comes from the fact, like, you know, an ion in common with the formula of the precipitate and one of the ions it forms when it sparingly dissolves. And that same ion is present already in solution. So another common ion would be, can anyone give an example of another ion that might already be in water?
Ag+.
Like that could be added if we add salt to water or if we use salt water. Chloride's going to be there. But what's another maybe anion that might already be present in some waters? Yeah.
And water? What the fuck?
Sodium and magnesium are pretty common.
Sodium, magnesium. Okay, that could be a common ion. Chances are,
Sodium,
though,
magnesium. What the fuck are you talking about?
sodium doesn't form any sparingly soluble solids with a lot of things.
Sodium, isn't it? Sodium salt.
So you're thinking of which ions do we typically see in sparingly soluble solids? Magnesium sometimes, but what anions maybe come to mind that seem to be in water sometimes?
Fluoride. Fuck's sakes. Fluoride. Say fluoride.
When you say anion, do you mean negative?
Exactly
It's
what I was
carbonate.
Fluoride.
Carbonate
Fluoride.
could be one.
Carbonate.
Fluoride doesn't form too many sparingly soluble solids.
Fuck!
I'm thinking of,
Calcium.
calcium can sometimes form some sparingly soluble solids.
Calcium's not an anion.
We should look at our solubility rules, I think, a little bit later. I'm thinking like hydroxide. You know, at certain pHs, you're just going to have a natural source of hydroxide.
Hydroxide already, sorry.
No, I've just said chloride, right? In seawater. But if you had fresh water, maybe the pH is a bit high in that water, you know, and so the presence of some natural hydroxide ions would cause the shift towards the left, because if you have a common ion where some metal could precipitate out with that hydroxide.
Out.
So let's apply this now to math, okay? We're going to do a little bit of calculations proving that when these common ions are present, solubility is reduced. So guess what we're going to be calculating? We're going to be calculating solubility when a common ion is present. So it's very similar to what we did last class, but we need to make sure our calculations include the concentration of that common ion. So here's an example. What is the solubility of silver chloride in this solution with a given concentration? Okay?
Easy.
In a solution of salt water. Okay, so we know the concentration of the salt water, and we're just trying to figure out what S is equal to. So we're solving for S, same as normal, and we're given the Ks constant, you know, the solubility product constant, that's given.
Cool.
And, okay, silver chloride, what sort of ratio are we looking at for our
Ratio.
equilibrium expression?
1 to 1.
It's just a 1-to-1 case.
Cool.
Right? Now,
Doesn't
in a
matter, fuck,
1-to-1
we've got
case, this is
0.0025 moles
our
of
expression
CL
where
minus.
the
Easy.
concentration of silver
K equals,
is
you've got Ag
multiplied by
plus.
the concentration
Easy.
of chloride. And it's all
That's
equal to that
solubility of
Ks
AgCl.
constant, right?
How much
So,
concentration of Ag?
Do we know either of these
That's
concentrations
fucking
yet?
Easy. Plus S?
Turns out we
Fuck,
kind of
plus
do.
S.
We can
This
introduce
is so
variables
small.
to
We don't
represent
even
the
need that shit.
concentrations we want to solve for.
S
So
sounds
S
right,
for
0.0025.
solubility of the overall compound, and because it's a 1-to-1 ratio,
Easy.
silver's
That's fucking easy.
concentrate
Easy.
two
Tell me something more.
concentrations
Tell me
together,
something
we'd
about
get a quadratic. Because we would have S.
We get a fucking quadratic.
Yes.
Cool. One thing I want to go over before we finish up this topic for today.
Okay.
Let's prove that this assumption is valid.
Alright.
Cool?
Fuck it.
So, I made an assumption that all chloride ions only come from the source of the salt.
Yeah, okay, assumption is right. That's all you got to say? Right, dope. End of video. Easy. Alright. That's it for the Flynn Nation podcast, Haru. How was life going for you though, Flynn? Life's going pretty good for me. Today is the 13th of November 2021. Moving to Christchurch, February. To go down there. That'll be fun. Fun on the bum. And that'll be an engineer. Hopefully apply my skills and make a business, an engineering business. Have you got a girlfriend yet? Oh my god. That's what I really need in life. I've got some pillars missing in my life. Kind of makes me sad. I need a chick. And I need God. I need God too. Did you find God, Flynn? Did you find him? Is he in your heart? Is he in here, Flynn? Please tell me he is. You know, right now I've got 3 pillars mainly. Schoolwork, gym, business side thing. So that's just like TikTok and Trade Me. I can get some more pillars. Maybe I probably won't try and get a girlfriend now. Now that I'm gonna move to Christchurch soon, that'll be a bit of an L. But maybe I'll look into some things. I'm gonna look into some things. Actually, on my to-do today. Set aside time to look to CJ branded dropshipping. My cousin did the exact same product I was wanting to do with CJ dropshipping. Fucking dope. I'm gonna look into it, see if I can get a bit of a shitty product going, and then see if I can sell to my customer. And then actually have a product ready to test it out. Build a bit of an audience as well. Build a fan base around the product too. That'd be cool. That would be cool. And then hold Alibaba inventory. That's definitely the plan. So glad my cousin told me that. I haven't been looking to dropship for ages, but I'll get back into that. I've got enough time to too. Got enough time. And remember to set aside time to read Bible. I've started reading the Bible, but I need to read it more seriously. I'm reading it like it's a fucking fictional book. I'm waiting for the setups and the payoffs. You know, there were quite a few pages that are just talking about God's ancestors. I'm like, surely this is going to pay off. No. They don't understand setup and payoff in the Bible. Because I'm reading it like it's a fucking kid. It's a fucking fictional book instead of a fucking religious text. But anyways, my name is Flynn Wilson. Your name's also probably Flynn Wilson, or else family of Flynn Wilson, or else friends of Flynn Wilson, or else I blew the fuck up somehow. Or else the YouTube algorithm is recommending random videos from really far ago. It's 2021 right now. I don't know how far into the future we are watching. How is virtual reality? I'm going to get into that space. That could be a chance for me to blow up, because I'm going to be early into the virtual reality zone, into the meta zone. Yeah, Facebook changed its name to Meta. It's more leaning in towards the it's early. It's an early move into virtual reality, but that's the next step. Right now, a lot of people are feeling like we're taking the next step into something big, kind of like the internet was back in the past. This virtual reality, NFTs, it's seeming a lot more, it's coming up on us now. It's going to be fun. It's going to be fun on the bun, and I'm going to be there. I'm going to be one of the first motherfuckers. I'm going to be the first motherfucker there. No one else is there yet. There are some motherfuckers there, but I'm going to be there soon. I'm going to be there quick. I'm going to be on it. Right? Anyways, my name is Flynn Wilson. I'll see you later.